Alright, let's do some quadratics. So these examples at the start of chapter 15 are to help you develop the skill of graphing quadratics without a calculator. So all that stuff you learned in grade 10, all those skills with quadratics, now is a really good time to bust them out. Okay, anyway, let's get started. 15.1. Match each equation to the corresponding graph. Okay, so let's have a look at these equations right now. They're all in standard form. So ax squared plus bx plus c. Now, from this form, we can figure out which way the graph goes. So whether it's a smiley face or a sad face, and where the y-intercept is. So graph 1, the a value should be negative, all right, because it's a sad face. And the y-intercept, we see that the y-intercept is less than 0, so it must be c. Now number 2, okay, again, a should be negative and c should be positive, so this must be a, and that just leaves us with b for this one. Let's confirm. So a is positive, yep, and c should be negative, which it is. All right, so a nice easy one to start us off with. Let's move on. Sketch the graph without a calculator, labeling any axes intercepts. Okay, let's go ahead and do that. Excuse me. So let's see, what can we do here to make things a little bit easier for us? Well, let's factorize out a 2. So 2 outside of x squared, take 8x plus 15. All right, because now we can factorize it, and once we factorize it, it'll tell us the zeros. So let's do that. Now there are other ways you can go about doing this, but this way might be more efficient. So we want two numbers that multiply to 15 add to negative 8. So we have negative 5 and x take 3. All right. So show our working. So find the x-intercepts, and they're at y equals 0. Well, straight up we know that y-intercept is 0, 30, because we've started off in standard form. And then x-intercepts at y equals 0, so 0 equals 2, take 2 outside of x take 5, x take 3. Using the null factor law, x equals 5 or x equals 3. So there's our x-intercepts, 5, 0, 3, 0. Y-intercept is at 0, 30. And okay, it doesn't actually need any more information right now, so let's just graph this. Alright, so draw up a set of axes here. Label your x and y axes. Determine your scale. Maybe I just go up in tens on my y-axis, because there's my y-intercept, 0, 30, and nice and wide on my x-axis. So I've got x-intercepts at 3 and 5. So the graph, the parabola, should look something, whoops. Now the turning point will occur at 4, because that's halfway between our two x-intercepts. So we're not asked to find it right now, but we just need to also show that's where the turning point is. So it should look something, whoops, like this. Alright, done. Oh, almost done. So 5, 0, 3, 0. Okay, now we're done. Let's keep going. Find the equation of the graph below in the form y equals a squared plus bx plus c. Okay, so let's just use whatever information we've been given, and if we need to, at the end, we'll rearrange the equation into the proper form that we've been asked. So, right, what we've been given are the two x-intercepts and a y-intercept, all right? So anytime you've been given two x-intercepts, two zeros, just use the x-intercept form. So y equals a x take negative 2, x take 4. So we have a outside of x plus 2, x minus 4. Now, let's sub in the 0.08. Alright, so let's just use the other point that we found, sub it in to find a. So it's going to be 8 equals a outside of 0 plus 2 is 2, 0 take 4 is negative 4. So that's 8 equals negative 8a, so a equals negative 1. Alright, so our equation, so y equals negative x plus 2, x take 4, and then we just need to expand all this into standard form. So x squared take 2x take 8 equals negative x squared plus 2x plus 8. And is that what we want? Yep, and we're done. Okay, 15.4. Express x squared take 10x plus 7 in the form of x minus a squared plus k. Okay, so if we want to go from standard form to turning point form, we need to complete the squares. So let's do that for part A. So f of x equals x squared take 10x. Now if I want to complete the square, okay, half of 10 is 5, square that is 25. Okay, plus 7, but since I added 25, I need to take away 25, otherwise my function has changed. So this is a way you can do it quickly. So we have x take 5 squared. Now we can factorize the perfect square. And that's what, take 18. Done. Hence, find the coordinates of the vertex. Okay, so if the quadratic is already in this form, the vertex is going to be at 5, negative 18, or the turning point. 15.5. So we're going from standard to turning point form, so we're going to have to complete the square again. Now, we see that when you complete the square, you want to make a equal 1. So right now we have 3x squared. We want x squared, right? So we have to factorize out the 3. Or just do that, just make things so much easier. Let's get into it. So f of x equals, okay, now you don't have to factorize the whole thing, because if we tried to factorize all 3 terms, we'd have to use 4 on 3. We have to divide the 4 by 3, right, and get a fraction. So you'll still get the same answer no matter which way you do it, but you can just factorize the first 2 terms like so. That's probably easier in this particular scenario. So let's complete the square for the expression in the brackets, right? So we want x squared plus 3x. Now we need to half 3 and square it. So that's 9 on 4. So, all right, so 3 on 2 is half of 3. Square that, we have 9 on 4. All right, that gives us a perfect square. Now we also need to take away 9 on 4, because otherwise we're just adding 9 on 4 and changing our equation. So we need to take that away to essentially make a 0. So we haven't changed the equation. All right, it's like adding 0 to the equation. So like that. Now we can complete the square. So this becomes x plus 3 on 2 squared. Oh, all right, and then take the 9 on 4, and then plus 4. I almost mucked that up. And then we don't want the square bracket, so let's expand. So now we have 3 outside of x plus 3 on 2 squared. Take 27 on 4 plus 4, which ends up being 3 outside of x plus 3 on 2 squared. Now 4 is the same as 16 on 4, so negative 27 plus 16 is negative 11 on 4. Now we're done. Okay. So if we now B, hence find the equation of the line of symmetry. Okay, so remember that a parabola is symmetrical about the straight line that passes through the vertex. So let's just identify the vertex at negative 3 on 2, because there's plus, that means our x coordinate is negative, and negative 11 on 4, that doesn't change. So line of symmetry is x equals negative 3 on 2. Find the equation of the parabola shown below. All right, let's see what, so we need to develop an equation. Let's think about what information we've been given. All right, we have a turning point. We don't know where the zeros are, but we have the y-intercept, right? So turning point, well, let's just use vertex or turning point form. So y equals a bracket x take negative 2 squared plus k, which is negative 5. Simplify, y equals a bracket x plus 2 squared minus 5. And now all that's left to do is figure out what a is. So we sub in another point, so sub 0, 7. So we have 7 equals a, 2 squared take 5. We can solve this in one go. So 12 divided by 4, a equals 3. So therefore y equals 3 outside of x plus 2 squared take 5. Okay, that's all the examples for you. Now you can go ahead and try 15a. Now this is a very important skill that you really want to master, so make sure you invest the time practicing sketching quadratics without calculators.